Good morning, my dear friends. See now we shall go to the second problem. Okay, I will read the problem now. A simply supported PSC beam of cross section 500 mm by 800 mm is loaded as shown in figure. Okay, find the fiber stresses at midspan by two methods. If the shape of the tendon is parabolic with a sag of 200 mm at midspan. Okay, at midspan it has got a sag of 200 mm. Okay, at midspan with the tendons passing through the centroid of the section at the ends. The pre-stressing force is 1200 kilonewton. See now let me explain this problem now. Okay, he has got a PSC beam wherein he has applied a pre-stressing force of 1200 kilonewton, and the cable is now laid parabolic in this way. Okay, uh, in this parabolic way the cable is now laid. Okay, see now the cable is passing through the CGS at two ends. Okay, here, but at midspan it has got an eccentricity of 200 mm. Okay, 200 mm is the eccentricity, and the loads acting are the UDL is 9.6 kilonewton per meter or 9600 newton per meter. Along with this, it has got one concentrated load of 150 kilonewton. Okay, with this, he has asked you to find out the stresses at the span section. The span of the beam is 10 meter. Okay, so now let us begin with the problem now. So given the pressing force F is 1200 kilonewton, so it is 1200 into 1000 newtons. Area we can easily calculate because the area is now, okay, it is 300 mm by 500 mm. Am I right, sir? No, the excuse me, 500 mm by 800 mm is the cross sectional area. Okay, so area can be now easily calculated. 500 mm into 800 mm, it is 4 lakh mm square. Similarly, I can calculate even the moment of inertia also. It is BD cube by 12. Okay, 500 into 800 mm cube divided by 12. It will give you so much. Okay, so now YT and YBs also can be now easily calculated. See now, since this depth is now 800 mm. Okay, YT is 400 and YB is also now 400 mm. Okay, so YT and YB is 400 mm, and eccentricity, as you know, it is 200 mm. Okay, so all these data is now given. Okay, so we shall try to see now how exactly it can be now solved. See now, one more important thing is now I would like to first calculate the bending moment at its span. See now, bending moment is due to two things. One is you have got UDL also. Because of this UDL, it is WL square by 8 plus you have got a point load. So due to the point load, it is WL by 4. So when I add these two, I will get the total bending moment at its span. So W you know, okay, UDL value you know, okay, you have put, and the span you know, okay, divided by 8 plus capital W, in the sense the point load intensity also you know, okay, span I know, and divided by 4. So it will give me 495000 Newton meter, or into 1000 will give me Newton mm. Okay, so this is the bending moment which I have calculated for this beam. Okay, so now let us go to now the stress concept. Okay, so by this stress concept, you know that, oh sir, no, by this stress concept, okay, FT, in the sense now top fiber stress is given by, okay, F by A plus or minus FEYT by I plus or minus MYT by I. Okay, this is the equation for your by your stress concept to find out the FT value. Okay, so F I know, okay, precessing force I know, area we have calculated. Okay, again F value I know, eccentricity, as you know by now, since the cable is below the CGC, okay, I am assigning E as minus sign. Okay, minus 200 mm. Okay, so you know that the eccentricity is below CGC. Okay, so I have assigned E with a minus sign. 200 mm. And now coming to YT, Baba, YT value, since it is up above the CGC, it is a plus 400. Okay, YT is also 400 and YB is also 400, but YT value is now plus 400 because it is above CGC. Divided by I value I have put, and M also you know. Okay, again YT is plus 400 divided by I value you have put. Okay, so you will get 3, in the F by A term is 3, FEYT by I term will be now minus 4.5, and MYT by I is now 9.3. When you add them algebraically, you will get plus 7.8 Newton per mm square. In the sense, plus indicates that it is compression. Okay, that's one thing. So now, similarly, I think you can easily find out the resultant stress at the bottom fiber, FB. Okay, it is again now, if I want to write the formula for FB, it is F by A plus or minus FEYB by I plus or minus MYB by I. Am I right? So F value I have written, A value I have written, F is F, again E is minus 200 mm only, and now YB, okay sir, now it is a minus 400 mm. Okay, I value I have written, and M is here, again YB value is now minus 400 divided by so much. So again you will get these values, and the resultant is now, if you add them algebraically, you will get minus 1.8 Newton per mm square. Baba, minus sign indicates that it is a tension. Okay, minus sign indicates that it is tension. So but now I think I can easily draw the stress distribution diagram by using these values now. Okay, so the stress distribution can be drawn like this. Okay, so because of this F by A term, it is like this. FEYT by I term will be like this, and MYT by I term will be like this. So when I add them algebraically, I will get the resultant stress. So the resultant stress is plus 7.8 on the top and minus 1.8 at the bottom. So minus indicates that it is tension. So but now this is how you can draw the stress distribution in PSC beam by using the stress concept. Okay, now we shall go for the strength concept. Okay, so now in strength concept, you know that F is equal to C. So F value, you know that it is now 12 lakh, or it's equal to C now. Okay, so now also I can easily calculate the lever arm A. It is M by C or M by F. So M also you know. Okay, C also you know. So it will give me so much. Okay, this is your lever arm A. Okay, 412 mm. So once I know the lever arm, I think you can easily calculate your H. Okay, H is given by A minus E. A I know, E is eccentricity, so you will get H value as so much. So once you know the H value, by using your strength concept, you can easily find out the FT, top fiber stress. Okay, top fiber stress is now C by A plus or minus CHYT by I. Okay, C value I know, A value I know, again C value, H just now you have found it is 212.5, YT as you know it is a plus 400 divided by I. Okay, so you will get so much. So the resultant is resultant top fiber stress is 7 plus 7.78. Okay, as you have obtained so it is now compression. Similarly, bottom fiber stress FB, now again the same equation, C by A plus or minus CHYB by I now it is now. Okay, it is CHYB by I. Okay, so put all the values, you will get minus 1.78 Newton per mm square. It is tension. If you just see the values obtained from your stress concept and strength concept are both are same. Okay, so whether you use stress concept or strength concept, the values will be same. Okay, thank you very much.